There are many applications that involve the law of sines. Let's look at one right now. To measure the height of a mountain, a surveyor takes two sightings of the peak at a distance 900 meters apart on a direct line to the mountain. The first observation results in an angle of elevation of 47 degrees, whereas the second results in an angle of elevation of 35 degrees. If the transit is 2 meters high, what is the height h of the mountain? To help visualize the problem, we've drawn the figure here. Here's the guy standing from the mountain and has an angle of elevation to the height of the mountain at 47 degrees. He's pulled 900 meters back and gets an angle of elevation of 35 degrees. Because the transit is 2 meters off of the ground, we have that the height of the mountain is going to be the length of this side of the triangle plus 2 meters. So let's draw a figure to represent this situation. What we have drawn here is our triangles. What we need to determine is the value of B, the length of this side of the triangle. How are we going to go about doing that? Well, what we should notice right off the bat is that we have this angle 35 degrees known. This angle is 47 degrees, so the value of gamma is going to be equal to 180 degrees minus 47 degrees, because these are supplementary angles. So gamma is going to be equal to 133 degrees. Because gamma is equal to 133 degrees, we can then find the measure of the angle alpha. We can find alpha to equal 180 degrees minus gamma, 133 degrees, minus beta of 35 degrees. The result is that alpha is equal to 12 degrees. Now that I know alpha and I know gamma and then I know beta, I can use that information to find the value of, say, C over here. I can find C because I know the sine of alpha is going to be the sine of 12 degrees over C is 900. Over A is 900, equals the sine of gamma, 133 degrees, over C. So then C is going to equal 900 times the sine of 133 degrees over the sine of 12 degrees. What we get is that C is equal to 3,165.86. Now remember, my ultimate task here is to find the value of B. Well, now that I know C, and I know that this is a right angle right here, I can find that the sine of 35 degrees is equal to opposite over hypotenuse, because C is the hypotenuse of this right triangle. So we get that the sine of 35 degrees equals B over C is 3165.86. So that B is going to equal 3165.86 times the sine of 35 degrees. We get that B is equal to 1815.86, which is about 1,816 meters. So the value of B from here to here is 1816, but don't forget that the transit's 2 meters off the ground, so the height of the mountain, H, is the 1816 plus 2, or 1,818 meters.